Yeah. All right. Wait. So double check your work. Few things that we have. You need to know that 1 pound is 16 ounces. 1 gallon is 3.785 liters. If you didn't know that, I'm pretty sure you can utilize the cover of your planner, the internet, science book, someplace. There's not every conversion is necessarily going to be available always, but I'm not expecting you to have them memorized. So as we go through them, Moon's 250,000 miles away. How many feet from Earth is it? So 250,000 miles. I put it over 1. Then I multiply by 5,280 feet over 1 mile. That would then allow mile and mile. Oops. That would allow mile and mile to cancel out, leaving our leaving us at 1,320,000,000 feet away. And then a family pool holds 10,000 gallons of water. How many cubic meters that is? So the thing is, when you're talking about volume, a gallon is already a three-dimensional object. Okay? And then a cubic meter is also a three-dimensional object, so there's not a conversion you have to do with that. So you have 10,000 gallons, put it over 1. This way, gallons and gallons is going to reduce. And then I know that 3.785 liters is 1 gallon. And then I can convert that and that. And I know that from above that 1 cubic meter is equal to 1,000 liters. So if you go 10,000 times 3.785 divided by 1,000, you're going to get 37.85 cubic meters of water. Okay, so remember, cubic meter is 1 meter by 1 meter by 1 meter. Think about a big box that would do that. Number 3, the average American student spends 330 minutes per day in class. How many seconds per day is this? So I can keep the day, but I have to convert the minutes to seconds. So again, I have 330 minutes per day. So I know that 60 seconds is 1 minute. So now minutes is going to cancel out, and this is going to allow us to have seconds over day. So if you multiply the two of these, you're going to get 19,800 seconds per day. That's how long you spend in a class in school. How many seconds are there in a year? So I have 1 year. I know that 365.25 days is 1 year. So now years is going to be able to cancel out. And then I know that 24 hours is in 1 day. So that means that day will cancel out. And then I have 24 hours, or 60 minutes in an hour. So hours is going to cancel out. And then I know that 60 seconds is 1 minute, and that allows us to cancel out minute. So if you multiply 1 times this, times this, times this, times this, you come up with 3,557,000. What? What? What is what? 31,057,600. Right? I had to write it sideways. Sorry. All right. Let's see if I move this down. Does the ink stay there? Yes, it does. All right. Good. All right. Lake Michigan holds 1.3 times 10 to the 15 gallons of water. How many liters is this? Well, again, you have to realize that there are 3.785 liters per 1 gallon. So you're just going to multiply straight across this to this. On most calculators, 1.3 times 10 to the third, you can use the E button. So it could be like that if you have the TI-84, 83, or 86, or 89. So the E button is the second of, I believe, the one right above the 7. I believe. It says EE. There's 2 capital E's, so you just push second E, 1.30, second E, 15. And then if you multiply this times this, you find out it comes out to roughly 4.921 times 10 to the 15 liters. Pepsi puts out 355 milliliters of pop in a can. How many cubic meters is this? All right, so you have to know that a milliliter is three-dimensional already. It's a liquid. Okay, so a cubic meter. So you have to know that 1 cubic meter is the same as 1,000,000 milliliters. Okay, how I know that is, wait, I'm over that. It's not 1,000,000. Is it 1,000,000? Oh, it should be 1,000 milliliters. So this should move over. It should be 0.355 milliliters cubed. Sorry about that. Yeah.
I got the answer in scientific nutrition.
So
I find, like,
3.55 times 10 to the first.
-4 if I did. But that was because.
Oh, did you use it?
Yeah.
When I had, okay, yeah, you'd be okay. Again, we're just practicing them, and I made an error already. Chicago uses 1.2 times 10 to the 9 gallons of water per day. How many gallons per second must be pumped from the lake? How many gallons per second must be pumped from the lake every second to supply the city? So, how many gallons per second must be pumped every second? I think it was redundant. I think how many gallons per second must be pumped from the lake to supply the city? God bless you. So I'm going to go 1.2 times 10 to the 9 gallons over 1 day per day. So now if I do 1 day is 24 hours, so that's good. I know that 1 hour is 60 minutes, so I'm going to cancel those. I know that 1 minute is 60 seconds. I cancel that. So anywhere is a denominator will be division. So I'm going to go 1.2 times 10 to the 9th, which you get on your calculator. A lot of you could do this. 1.2 E9. That's the same thing, scientific notation. Divided by 24, enter. Divided by 60, enter. Divided by 60, enter. And that's going to tell you that you need to pump 25,462.96 gallons per second out of the lake in order to get enough for the city. 60 miles per hour is how many feet per second? And this is actually a pretty good question because most of the time people are driving. If it's a 45-mile-an-hour zone, most people are doing close to 60 miles an hour. Okay, I know some people say, well, the rule is as long as you're not doing over 10 miles per hour, you won't get a ticket. Theoretically, police aren't going to pull you over if you're doing 9 over. Some people will push the issue. But let's convert to 60 miles per hour. So 60 miles in 1 hour. I know that 1 hour is 60 minutes. Now that hour an hour. So now if I just did this, 60 divided by 60, that's going to be miles per minute. And then I want minutes to seconds. So 1 minute is 60 seconds, and this is going to allow me to cancel minutes to minutes. And then I know that 5,280 feet is 1 mile. So this mile, look how far this is going to cancel. From here all the way to here. So my units on top is going to be feet. My units on bottom is going to be seconds. So I'm going to go 60 divided by 60, which is 1. 1 divided by another 60. And whatever that answer is, I'm going to multiply by 5,280 feet. So that means that if you're doing 60 miles per hour, I mean, I want you to think about this. I mean, truly think about this. That's 88 feet per second. Okay? 60 miles per hour. That's not a speed that you will not have traveled. That's not like, oh, that's an outrageous speed. I'll never go that fast or never go that slow. 60 miles an hour, you usually will. You got a lot of folks, okay, and I know probably not you, but a lot of folks that they got to check that cell phone message. Okay, ready? 1 second. 1001. There's 88 feet. You take your eyes off the road to look at a text message. 88 feet is this classroom, the next classroom, and a little bit of the next classroom. Is that a far enough distance? I mean, you got to think about it. It's, you know, and can you read a whole text message in a minute? Sometimes you're scrolling down it, right? I mean, you have a vehicle that weighs a large amount of weight that is doing 88 feet in a second when it's doing 60 miles per hour. A lot of space can take place in 88 feet. A lot of things. So I would caution all of you, please, the text isn't worth you making a mistake that could affect the rest of your life. Okay, I'm just telling you that. I mean, I care way too deeply about you, and I so dislike to hear if any of you were to have been involved in an accident or had caused an accident, because that message couldn't wait. Okay? I mean, we're all here for a limited amount of time, but I want to spend as much time with you guys here as possible. Okay? Love you guys too much not to have you. Love you guys too much not to. I mean, I want to teach you guys grandkids. Well, no, I'll probably teach you kids. I'm only going to teach for 20 more years. So hopefully I have your kids. I feel like I'm getting old. I saw this morning one of my former students that I taught in Las Vegas, his friends on Facebook. It's his birthday today. He's 37. I've been teaching a long time. 37 years old? I'm not old enough to have a student that is now 37. Those darn kids, you're not allowed to get older. That's beautiful. That is the beautiful thing about being a teacher, because I will always look at you as you right now. George, you'll see me 20 years from now. Hey, Mr. Sherman, I'll see George at your age right now. How old are you, George? 15? 14? I'll see you at 14 years old for the rest of your life. So you're forever young for me. Sorry. So is Steven. So is Ray. So is everybody. I can't believe this student's 37 because I still see him as a 17-year-old kid when I had him 20 years ago. Kind of silly. If a person weighs 125 pounds, 8 ounces, how much does he weigh? 8 ounces is a half a pound, so that's 125.5 pounds. How many milligrams does he weigh? So I know that in every 1 kilogram, there's 2.24 pounds, so pounds is going to cancel out. I also know that there are 1,000,000 milligrams in a kilogram. Okay, so now kilogram is going to cancel out. So this is going to leave our answer in milligrams. So this 125-pound person is going to be 56,941,923.77 milligrams in weight. Dude, that guy's heavy. All right, this is from Santa Maria to Los Alamos. Is 16.25 miles. What is the distance in centimeters? Well, I know that 1 mile is the same thing as 5,280 feet. So I did that. And then I know that 12 inches is in a foot. So a foot and feet is the same thing. Those cancel. And then I know that there are 2.54 centimeters in every inch. Now my inches are going to cancel out. You notice it's canceling top to bottom. That's the important thing to see. So if you multiply these together, you wind up realizing it's 2,615,184 centimeters to get from Santa Maria to Los Alamos. All right, Santa Maria has an elevation of 6.3 times 10 to the 5th millimeters. How many kilometers is an elevation? So I know that 1 kilometer is 1,000,000 millimeters. So millimeters cancels out. So I go 6.3. So on your calculator, you go 6.3 e to the 5 divided by 1,000,000. So that's 0.63 kilometers. 0.63 above sea level. If a projectile travels 3.0 times 10 to the 3rd feet in 1 second, so that's 3,000 feet in a second, how far will it travel in 18 minutes? Okay. So let's see. It does that feet per second. So there are 60 seconds in 1 minute, so that means seconds and seconds are going to cancel out. And, so if I find just this answer here, that's going to tell me how far I'll travel in 1 minute, and then I know that 18 minutes needs to apply, so I'll multiply by 18. So it's going to travel 3,240,000 feet in 18 minutes. And a small herd of cattle consumes 14 bales of hay in 2 weeks. How many bales will this consume in a year? So 14 bales per 2 weeks. There's 52 weeks in a year. Weeks now cancels with weeks. So you have 14 divided by 2, which is 7. 7 times 52 comes out to 364 bales per year. And the rest of the problems I don't like. They are, I mean I like because they're way too intense, but I don't think I'm going to give you anything quite that tough. All right? sense? All right, and let's make that. How you guys feel? All right? Okay. So, I have a small lesson, and then I have a pop quiz, which we grade as a class that I was going to give you. Reese is going to cry himself now, but that's okay. All right, so let me go through today's lesson. It's not horrible, but it's using a term that you all know about. If I had 2 over 3 is equal to x over 7, what math are you going to use to solve for x? What do you know it as? Multiplication. What kind of multiplication? Cross multiplication. Now, I'm going to tell you this. Cross multiplication is always totally chill for you to use with me. I get it. But sometimes there's some math teachers going, no, it's not called cross multiplication. It is the product of the means is equal to the product of the extremes. The product of the means, product means multiplication. The product of this cross is equal to the product of that cross. So why don't you just say cross multiplication? Because they want to sound smart. Smart. Okay? I'm sorry, I'm not that guy. I'm not so sophisticated that I have to say, oh, it's got to be the product. So, cross multiplication. So, real quick, we're going to go 2 times 7 is 14. X times 3 is 3x. And then how do I solve? Divide by 3. So we find that x is equal to 14 over 3. Pretty easy. Okay, so that's first step. So cross multiplication, pretty sure you've done quite a few times. Okay? Can I clear that? All right, so the next thing we're going to use is it's a template that we'll always use for this type of thing, and it's pretty useful. Is over of equals percent over 100. What is the only constant up there? 100. Good. Only constant up there is 100. Meaning the 100 stays as 100 all the time. Okay? What you doing there, buddy? Can I have your ID and your phone, please? Pick it up from your dean later today. Just bring it up, put it up on my desk. Both your ID and your phone, please. All right, so is over of equals percent over 100. Is over of equals percent over 100. It's a template. We're going to substitute in for is. We're going to substitute in for of. We're going to substitute in for percent. The 100 stays 100. So first thing might be is what number is 15% of 90? What number is 15% of 90? Okay? So again, the is and the of. The is and the of are what should be sticking out, and the percent should be also sticking out. Do I have your ID, Casey? You have your ID? Okay. What number is? Where do I plug? What things get plugged in? 15 goes in for the percent. Awesome. 15 goes right there. Any other thoughts? Yeah. There you go. 90 goes for of. And then I'm going to use the variable x or whatever variable you choose for is in this case. So this is going to become x over 90 equals 15 over 100. Okay? Cross multiplication. Everyone have a calculator out? And what would 15 times 9 be? Or 15 times 90 be, please? Say that one more time.
1,350. 1,350.
1,350. How do I solve for x? How do I get x all by itself? Divide each side by 100. 1,350 divided by that is 13.5. 1.35. 1350 divided.
Yeah, you were wrong.
All right. So 13.5 is 15% of 90. Okay? So that's when we're substituting in for is. That's when is's are unknown. Make sense? Okay. I'm going to bring this down here. I'll bring up another one. Clear, right? Again, let's do is over of equals percent over 100. Still with me?
Yes.
And this is our template. What's our constant? 100. That means it's always going to the same. Okay. Find. Let's not do that. 36 is 4% of what number?
36
Okay. 36 is. 36 is 4% of what number? Of what number? That's going to be x. Where do I plug? Where goes plug? Where? Yeah. 36 is my is. So 4% goes there. And of is x. So let's do it. 36 over x equals 4 over 100. Cross multiplication. 36 times 100 is 3,600. 4 times x is 4x. Divide each side by 4. X equals 900. So 36 is 4% of 900. 36 is 4% of 900. So the first one we did, so that was substituting for of. This one was substituting for is. Gotcha?
Wait, can you do one more problem like that?
Well, Reese,
Yes.
can you ever identify the word is? And can you identify the word of?
Is on the top and of on the bottom?
Is over of equals percent over 100. And in a problem, you're going to have the word is, you're going to have the word of every time. Now, the percent should be obvious because the percent has what attached to it every time.
Percent?
Yes. Okay? So really what you're going to do is you're going to look for where the is falling into the problem and where the of is falling into the problem.
Right.
Sometimes you might be missing the of. It might say 20% of 40. 20%.
Wait, can you write that down?
Well, I will.
I'm better with like visual stuff.
Visual stuff. I'll draw you a picture. All right. All right. Again, is over of equals percent over 100. Still with me? What's my constant? 100. That means I'm not substituting in for it. So 32 is what percent of 70? That's a question mark. Reese,
Yo.
is closest to what number? Up there in my phrase.
32 is what percent?
So which number is closest to?
Of 32.
Does 32 have a percent on it?
No.
Good. Guess what? Where do you think that goes?
Where the
What?
is?
Yeah, there you go. Of is closest to what number?
70.
Does 70 have a percent on it?
Yes. Oh, I'm sorry, no.
No. Okay. Where do you think that goes?
Right where the of is.
What am I looking for?
We're looking for the top number for the percent.
So I'm looking for percent, so I'm going to put in x. So x is going to go in for there. So 32 over 70 equals percent x over 100. Cross multiplication, 32 times 100, 3200. 70 times x, 70x. Divide each side by 70. So x equals, how much? 60? No? 25? I don't know.
45.7.
45.71, rounded?
Yeah.
What do you think I want with this answer? Huh? No? 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 Yeah. A number? No?
Oh,
Huh? Percentage. There you go. So 32 is 45.71% of 70. So when I'm looking for the percent, I want to make sure you put the percent sign in there. Okay? So sometimes you have an is, sometimes you have an of. Really how you're doing these problems is what number is closest to is? It's going to go for the is. What closest to of? Goes in for the of. The percent should be obvious. If it doesn't have a percent sign, don't put it. Okay? All right. I think you are going to be able to complete this worksheet. Okay, I want you to do, it's page 61, 62. And that's worksheet number 2 of this section. And I want you to skip 10 and 11 for now. We'll do those tomorrow. So that's what we're going to work on. And now we're going to do a pop quiz that we're going to grade as a class. If you're here, you get the points. If you're not, I don't put any points in for you, so it doesn't count for or against you. You guys ready for the pop quiz?
Yeah, man.
There's 2 of them. Right there, 6162, worksheet number 2. Yeah, start this quiz when you get it. You're working together, and you're gonna do great. Work with people.
Well, we get like dogs.
Is that
We get the split score.
no?
No.
Full points. Full points. Yes, guys and girls, if you work with each other on this, you get full points still. It's not divided up points.
Wait, do we have to
You have 6 minutes to do this. 6 minutes. Work with each other. 3, 2, 1. No more cussing. People, you have the lights on. All right, 3 feet to inches. I want to convert 3 feet into inches. What am I going to multiply? What's my next step? Go ahead, Reese.
So you see, 1 foot in inches is 12 inches.
Okay.
So all you have to do is like 3 times 12, and yeah.
So you told me inches is on top then?
Yes, and then.
Okay.
Yes.
And then 1 foot. And foot and feet are the same thing, right?
Correct.
All right. So you want to show like this. Also, this is over 1. Oh, good. Outlook's coming up. Get out of here. Get out of there. Ah. Dude. Good.
Oh my god.
Oh, get out of here. Over here. All right, so feet cancel with feet. 3 times 12, I get 36 inches. That should have been pretty quick. Pounds to grams. So LBS is how you represent pounds. Put that over 1. What's the conversion we know? Yo. Pounds to kilograms. How many? What do we know about that? 2.204 pounds is 1 kilogram. Okay? And that'll allow us to eliminate pounds. Then what do? How many grams are in a kilogram? 1 kilogram is 1,000 grams. By us doing this, LBS cancels LBS. kg cancels kg. Everything cancels out except for g. We want it to be in g, which is grams. So 10 divided by 2.204 times 1,000 is 10 divided by 2.2104, enter, times 1,000. 4,537.2. All right. 4,537.2 grams. All right, the last one, we have to convert two different things. I need to convert miles into feet, and I have to convert hours into seconds. So it's your choice where you want to start with this. I know that there are 5,280 feet in 1 mile. Why do I have mile on bottom, not on top?
Because miles don't
So they cancel. So right now, if I were to do this problem, my answer is going to come out to feet per hour. But I want it in feet per second. Okay, so my feet is good so far. The next part, I want to convert my hours. So I know that 1 hour is 60 minutes. And if I convert this, hour cancels with hour, so my answer would be in feet per minute now. But I want it feet per second. So the last step is I want to go, I know that 1 minute is 60 seconds. Now minutes cancel top to bottom. And that's going to give me my answer in feet per second. So you're going to go 75 times 5,280, enter. Divided by 60, enter. Divided by 60, enter. And I'm going to get 110 feet per second?
Yes.
Cool.
No, that's not.
Sweet. So everyone feel okay about what your homework is?
Yeah.
Everything A-okay?
Yeah.